In this part, we want to work on important ideas of UKMT Mathematical Olympiad for girls and related problems from BMO, AMC, SMT, HMMT 2023, 2022, and so on. AMC is American Mathematics Competition. We can say round one of USA BMO, British Mathematical Olympiad. The most two prestigious national Olympiad exams are for America and UK, and SMT Stanford Math Tournament, Harvard MIT Math Tournament. The ideas are we want to consider these 7 important ideas, and for each idea we want to solve related Mathematical Olympiad for girls, and also BMO round 1, sometimes round 2, AMC here again this problem of Mathematical Olympiad for girls 2022, BMO round 2 2023, AMC again, and these problems, these ideas. For example, we want to solve this problem from last HMMT 2023 Harvard MIT Math Tournament, and also geometric problems, and last problem of geometry of 2023 SMT Stanford Math Tournament. Okay, so in each topic there are 40-50 important ideas and formulas. If you want to learn them and wanted to solve more problems, feel free to send message to my WhatsApp number in the description and comments. So let's start with this idea concerning different modes and properties of. Let's first review the ideas concerning different modes, properties of n factorial, Legendre's formula, relationships between arithmetic sequence and mod. Concerning small examples, so much useful ideas of GCD, greatest common divisor, similar triangles, Pythagorean theorem, double Pythagorean theorem, Heron's formula, and many other important and basic ideas, cosine law, sine law, and also caseworks. Let's start with this one. Okay, so let's solve this problem in a new page. Last problem of 2022 Mathematical Olympiad for girls. It says given that m is a positive integer, what are the possibilities for the last digit of 2 to the m? So we consider 2 to the, because m is positive integer, so m, the minimum m is 1, is 2, 2 squared is 4. If you multiply by 2, it will be 8, 16. It will be 6, again 2 times 6, 2, 4, 8, 6. And pattern is this, the period is 4, length of period. Okay, so we solve this problem. Part 2, what are the possible remainders when 2 to the m is divided by 3? We can also solve it with mod, but if you check 2 to the m is 2, 2 to the 2 squared is 4, which is 1, 2 cubed is 2, 2 to the 4th is 1, and so on. Here it is 2 and 1, the period is 2. 2 marks. Next part. Find all positive integer values of n, a, and b with a at most b, such that n factorial equal. Here we can also solve it with mods, and we have some other problems related to this. If you want to learn them, feel free to send a message to my WhatsApp number in the description and comments. Okay. This is n factorial equal to 2 to the a, 2 to the b, and all of them are positive integer n, a, and b. Okay, justify carefully why there are no other possibilities. So here part A was a hint. But also, if you didn't have part A, in these types of problems, you should consider different mods. Here, because it says last digit, and when divided by 3, last digit means mod what? Mod 10. The remainder when divided by 3 is what? Mod 3. Okay, so let's consider first mod 3. We know n factorial equal to 2 to the a plus 2 to the b. So if n is 1, and also here, look, I can say in 90% of the problems in this exam and also other exams, AMC and BMO, especially BMO round 1, round 2, IMO, considering small examples can be so much useful. Here, n1, 1 factorial, which is 1. We cannot write it as 2 to the a plus 2 to the b because it says all of them are integer. It is at least 2 to the 1 plus 2 to the 1 is 4. So n1 doesn't work. And 2 also doesn't work. 2 factorial is 2. If n is 3, it will be 6. So we can consider n is at least 3. For n1 and 2 doesn't work. So if we consider mod 3, n factorial, mod 3 is 0 because n is at least 3. And now let's consider, for example, 2 to the a. 2 to the a, it depends on, for example, let's consider 2 to the k mod 3. It will be 1 if, let me write, 1, 2, 1, 2. Period is, if we want to consider mod 3, it will be 1. The first one, k is 1, is 2, 1, 2, 1. The period is 2. So we can say 2 to the k mod 3 is, so let me write it. We consider here, we write mod 3 here. Mod 3 is 1 under what condition? And 2 under what condition? If k is odd, we can conclude it is 2. If k is even, we can conclude it is 1. By the period also with modular we can prove. Now 2 to the a plus 2 to the b, 2 to the a plus 2 to the b, we know it's n factorial. N factorial is 0. Okay, mod 3. So, and we know 2 to the a, 2 to the b, mod 3 can be 2 or 1. And some of them is multiple of 3. So what can we conclude? Can both of them be 2? 2 plus 2, 4. No, it will be 1 mod 3. Can both 2 to the a, 2 to the b, each of them can be 1 or 2, 1 or 2. 1, 1 is not possible. 2, 2 is not possible. 1, 2 or 2, 1. So we can conclude from here, because the power when it is odd, the remainder is 2. When power is even, remainder is 1. We can conclude one of the power is even, for example, one of the power like here odd, or odd even. So we can conclude one of them odd, one of them even. The cases odd, even, or even odd. It is equivalent that a plus b is what? A plus b is odd. Okay, so it is the first condition that we have. Now let's consider here because we have last digit. Last digit is mod what? Is so much important. Remainder when divided by what? It is mod 10. Last two digits is remainder when divided by what? Mod 100. Okay, so we want to find n factorial mod 10. We want to see which result we can reach. If n is at least 5, look, for example, 1 times 2 times 3 times 4 times 5. If n is at least 5, because we have both 5 and 2, it will be multiple of 10. So if n is at least 5, case 1, then n factorial mod 10 is 0, means last digit is 0. Case 2 here, if we from previous case, we proved that n should be at least 3. So we should only check 3 and 4. If n is 3, then 3 factorial is 6. Is 2 to the a plus 2 to the b. And the problem says what? A and b, a is less than or equal to b, they are positive integers. So if we write powers of 2, 2 to the 1, 2 squared, 2 cubed, and so on, it will be what? It will be 2, 4, 8, and so on. Some of them equal to 6. So the only possible is 2, 4. Because the problem says a is at most less than or equal to b, we know 6 is 2 to the 1 plus 2 squared. So a is 1, b is 2 because a is less than or equal to b, and n is 3. So our first answer is this. Okay. Now in next case, we consider, let me add new page. Okay. So we should also check n4. If n is 4, then 4 factorial equals 2 to the a plus 2 to the b. 4 factorial is 24 equal to 2 to the a plus 2 to the b. So 2 to the a is 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, and so on. So it will be 2, 4, 8, 16, 32, and so on. Some of them equal to 24. 2 plus what is 24? 22. 22 is not power of 2, we cannot use 2. 4 plus what is 24 plus 20? 20 is not power of 2, we cannot use. 8 plus what is 24? 16. So the only possible case, 24 is 2 cubed plus 2 to the fourth. So here the answer, n is 4, a is 3, b is 4. Okay. It is second answer. Now, if here n is at least 5, so we've reached two answers for n3 and 4. Now here we can consider n is at least 5 and n factorial is 0 mod. Now, 2 to the k, last digit is 2 in part A. We proved 2, 4, 8, 6. And again, 2, 4, 8, 6. So we can consider 2 to the k mod 10 is congruent to 2, 4, 8, 6. If k is 4 cubed plus 1 because the period is 4, we can consider this one 4 cubed plus 2, this one 4 cubed plus 3, and this one 4 cubed. We have these four conditions. Now I want what 2 to the a plus 2 to the b equal to, in this case, n factorial, and n factorial is 0 mod 10. So we want to see what are the cases. So it can be 2 and 8, or we can switch 8 and 2, both of them. And here, whether the other case 4 and 6 or 6 and 4, okay? Now, in this case, a plus b will be what? 4 is what? For 2. 4 times something plus 1. 4, for example, q1 plus 1 for one of them. And the other one that is 8 is 4q2 plus 3. So 4q1, 4q2 becomes 4q3 plus 4, which is 4q4. But in previous part, let me consider this one as a star. We proved a plus b is odd. But here a plus b is not odd. By star we reach contradiction. Here a plus b will be what? A plus b is 4q plus 2, or we can say, for example, 4q5 plus 2. We don't want to use similar variables. Plus 4, 4, 6, 4q6. So sum of them is 4q7 plus 2. Again, because of a star, we said a plus b is also. In this case, also we've reached contradiction. So for this case 1, we don't have any answer. So our only answers are n4 and 3, and these two cases. Okay. So we solved this problem completely. And as, for example, here we've concept property of n factorial. N factorial after some number will be multiple of 10, after some number will be multiple of 6, and many other things like that. Now let me tell you Legendre's formula is what? For n factorial, it is important. Vp of n means power of p in n. For example, like what? V3, suppose p is prime. V3 of, for example, 12. If you prime factorize, it's power of 3. So it's 2 squared times 3. Power of 3 is what? 1. For example, V3 of 36 is what? Because power of 3 is 2 is 2. V3 of, for example, 27 is what? Is 3. V3 of 8 is what? 1. Because power of 0. Because power of 3 here is 0. It's 2 cubed. Now, I want to say Vp of n factorial equal to floor of n over p plus floor of n over p squared plus floor of n over p cubed, and so on. And let me tell you the reason is what? When we say n factorial, it is 1 times 2 times 3 times 2n. When we say n over p, we are calculating only multiples of p. Multiples of p. When we calculate here, we are calculating multiples of p squared. When we consider this, we are calculating multiples of p cubed. So here, when a number, for example, when we reach p cubed or something times p cubed, we calculate it 3 times, and it's okay because we should calculate it 3 times because we want to find power of p in n factorial. So this one will be the answer. Okay, so this formula is Legendre's formula, and if you wanted to solve more problems with this and wanted to learn more properties of n factorial, as I said before, feel free to send message my WhatsApp number in the description and comments. Now we want to solve these two problems. Problem 4 is easier of AMC. Let's solve that one first, then we will solve EMO round 1. Here it says what? Read the problem. The 6-digit number 202108 is prime for only one digit A. What is A? So let's check the choices first on. We consider, for example, is it multiple of 3 or not? For mod 3, we should consider sum of digits. 2 plus 0 plus 2 plus 1 plus A. It says it is prime. So it shouldn't be multiple of 3. So it will be 5 plus A mod 3. And it shouldn't be 0 because it is greater than 3 and prime, so shouldn't multiple of 3. So we conclude that A is not mod 3, A is not 1 mod 3. Otherwise it will be multiple of 3. So we rejected 1. What else? We rejected also this. Okay, 7. If it is 5 because of mod 5, it will be bad because then it will be multiple of 5. So now we have problem between 3 and 9. Mod 3, mod 9, mod 11 are so much useful. For mod 11, from right, you should consider plus minus. Why? Because 10 mod 11 is negative 1. Okay? And first, when we write this number, 202108, right digit is one's digit, but this one, because for example, we multiply it by 10, 10 is negative 1 mod 11. This one we multiply it by 10 squared, because it is in hundreds digit. So it is negative squared is plus. So that's the reason from right, you should consider plus minus alternatively to find mod 11. So it will be what? Negative 2, negative 2, negative 4, plus 1, negative 3. A minus 3. It shouldn't be 0 mod 11 because it is greater than 11, this number, and is prime. Why I say greater than 11? Because 11 is multiple of 11 and is prime. The only number that is multiple of 11 and prime is 11. If the number is greater than 11, it can and is prime, it cannot be multiple of 11. So by this case, we can reject this, which choice? 3 or 9? 3. Because 3 minus 3 is 0 mod 11. So here, because of 11, here we rejected because of 3, In one case is left this one. Okay? If you wanted to solve more problems of AMC and other exams with this idea, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay. Now let's read this problem of BMO Round 1 British Mathematical Olympiad 2020. In the equation, a to the AA plus AA equal to BBBCDED BEE BBB. The letters A, B, C, D, and E represent different base 10 digits. So it is so much important, different base 10 digits. So the right hand side is a 16-digit number. So if we calculate 1, 2, 3, 4, 5 times 3, 15 plus 1, 16 digits. So we conclude that B is not 0, okay? We've concluded that B is not 0. Given that C is 9, okay, C is 9, we want to find A, B, D, E. First here, it's good to consider which digit. Look, if you want to consider b, for example, right hand side, we don't know this number equal to what. If we can find a, we can find left hand side is what, so we can understand right hand side. So first thing to understand this problem is to find a. A is what? If a is 1, and here again considering a small example like previous problem. As I said, this idea is so much useful. 1 to the power of 11 plus 11. It is 12. It is bad because it doesn't have 16 digits. If a is 2, 2 to the 22 plus 22. 2 to the 10, it will be around what? Let's write 2 to the 10 times 2 to the 10 times 2 squared plus 22. 2 to the 10 is 1024 plus, times 1024 times 2 squared is 4 plus 22. So we can say it is less than here. Instead of 1024, we write 2000. Less than 2000 times 2000 times 4 plus 22. 4 times 2, 8 times 2, 16. 0, 0, 0, 0, 0, 0 plus 22. And then how many digits are there if we add 1, 2, 3, 4? It will be what? 16, 0, 0, 0, 0, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8. 8 digits. But here we need what? We need 16 digits. Right hand side. So this one, A2 is so much smaller. I want to say A is 3 because if you check also A4, if I check A4 and say A4 is so much large, then A is 3. 4 to the power of 44 plus 44. It will be 2 squared to the power of 44 plus 44. So it will be 2 to the power of 88 plus 44. It is greater than 2 to the 80. And this one is 2 to the 10 to the 8. And is equal to 1024 to the power of 8 and greater than 1000 to the power of 8. So it will be 10 cubed to the power of 8. So it will be 10 to the 24. So our number is greater than 1024. 10 to the 24 has how many digits? 25 digits. So our number has at least 25 digits, and that's a contradiction because it has 16 digits. So we conclude what? A is 3. Okay. Now we can copy this part. Let's paste it here. Okay, one way is to calculate 3 to the power of 33, and you can find B, C, D, E. Okay, I want to solve it with modulus. Okay, so one way you can do this as homework to reach 3 to the power of 33. So let me write 3 to the power of 33 plus 33. We know C is 9. Okay, the problem says so. B, let's write B9, DED, BEE, and BBB, and BBE. What are the digits that we want to find? We found A, we know C, we should find B, D, E. Okay. For finding E, what can we do? We can find only tens digit, ones digit, because we can consider mod 10. So 3 to the 33 plus 33 mod 10 equal to what? Left hand side is this, right hand side is E. So left hand side 3. Here you can find the pattern. For example, you can say 3, 9, and 3 times 10, 27, 7, 3 times 7, 21, and again 3, and so on. The pattern is 4, and because the remainder is 1, you can conclude it is 3. Another way is that when you want to calculate 3 to the 33 mod 10, you can say it is equal to 3 squared to the 16, 332 times 3. it will be 9 to the 16 times 3. 9 is what? Mod 10 is negative 1. Negative 1 to the 16 times 3, which is 1, which is 3 mod 10. Okay? So, this number with two ways, I told you, solution 1, solution 2. It is 3 plus 33 mod 10 is 36, which is 6 mod 10. So E is what? E is 6. Okay. So let's write it again. 3 to the 33 plus 33 equal to B. B 9. We want to replace E with 6. D 6D. B 6 B and B 6. Okay. Let's add new page. Now in this part, we want to find B. One way is to consider mod 100 to find last two digits. And it's not hard at all. But an easier way, we want to consider two important mods. Use mod 9 and mod 11. If we consider mod 9, left hand side is 3 to the 33 plus 33 mod 9. Obviously, 3 to the 33 is multiple of 9 because it is 3 times 3, 33 times. Only two of them are enough, 3 times 3. So 0 plus 33. 33 is what is 6 mod 9. Okay. Now, for this number, we know it is equal to sum of the digits. So, how many 6 are there? 1, 2, 3, 4. 4 times 6. Okay. 1, 2, 3, 4. How many B's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 9B, so it is 0 because 9 is 0. And now it's good to find D. How many 9s are there? 1 9. How many D's are there? 1, 2, 2D. It is what? Because left hand side is 6. It is 6 mod 9. Okay? 9B 9, 0. 4 times 6, 24. 24 plus 2D is congruent to 6 mod 9. Now, 24 is what is 6 mod 9 plus 2D is 6 mod 9. Then 2D is 0 mod 9. We can divide both sides by 2. And when we divide both sides by 2, it will be mod 9 over GCD of 9 and 2, which is 1. If you don't know these important things in mod or wanted to learn other tricks in mod, we have some important tricks that are useful in AMC, AME, BMO 1 and 2. If you want to learn them, feel free to send message my WhatsApp number in the description and comments. Okay, D is 0, and because D is a digit, D can be 0 or 9. Okay, so let me call it 1 because we need that. Now, in next step, let's consider mod. What number is useful? Mod 11. Okay, mod 11. Let's consider first left-hand side. 3 to the 33 plus 33 mod 11. If you consider 3 to the 33, you can say 3 squared is 9 to the 16 times 3. So 9 is what is negative 2 mod 11. Okay. Because it is 16, you can write it as 2 to the 16 times 3. Then we can write it as 2 to the 5 cubed. 15 times 2 times 3. And then mod 11, 2 to the 5 is 32 cubed times 2 times 3. 33 is multiple of 11, so it is negative 1 cubed times 2 times 3. So it will be negative 6 or 5. Because in mod 11, you can add 11. 11 plus minus 6 is 5. So it is 5 plus 33, which is 38. 38 mod 11 is 5. Okay? Now, here, for mod 11, the rule is from right, like previous problem of AMC, plus minus plus minus plus minus plus minus plus minus plus minus plus minus. Let me write plus minus. Okay. Now let's see. How many 6 we have? Plus 1, plus 1, plus 2, minus 1 will be plus 1. So 2 minus 1 is 1. 1 plus 1 is 2. 2. Okay, so 2 times 6. Let's calculate again. 6, 1, and then this 6, this 6, this 6. 3 of them plus, 1 of them minus, so it will be 2. Now let's consider b. These 2b will be cancelled. These 2b will be cancelled. This b minus plus will be cancelled. These plus minus b will be cancelled. Let's also cancel these 6. So 2 times 6. And here we have minus b. For d, we have minus 2d. Okay, and plus 9. It is what mod 11? It is 5 mod 11. Okay, let me check 5 mod 11. Yes. Now 2 times 6, 12. 12 plus 9, 21. 21 minus b minus 2d is congruent to 5 mod 11. So we can say 21 is what mod 11 is negative 1. So negative b, negative 2d, you take negative 1 to right side, 1 plus 5, 6 mod 11. So it will be b plus 2d is negative 6. We add 11, it's 5 mod 11. Now, we know d is 0 or 9. So let's check. If d equals 0, so b is 5 mod 11. So the only case is b equal to 5. If d equals what? D equals 9. From 1 we are considering these things. Then b plus 2 times 9, 18 is congruent to 5 mod 11. So b is what? B is 5. 18 is what? Mod 11 is 7. Or let's say negative 3, negative 4. So b is 4 plus 5, 9 mod 11. Let's check which of them possible. But here we have one problem because the problem says there are different digits. Here when b is 11, 9 mod 11, b is 9, so that's a contradiction because d is also 9. So d is 0, b is 5. Let me write. E was what? A was 3. And E is what? E is 6. Okay? Let me write it here. E is 6. And the problem wants what? The problem says find all digits, right? Given that these find it. So we found all of them. A3, E6, B5, D0. Okay. So we solved all these problems here. Let's work on next idea. Relationship between arithmetic sequence and mod concerning small examples. This problem is fourth problem of 22 UKMT Mathematical Olympiad for girls. And also this problem BM around 2 and this problem from AMC Fall 12A, AMC 2021, AMC 2022, BM around 1 2023. Okay, let's start with this problem. Okay. It says Freya Hillary play a game. Freya first chooses a positive integer a with a is from 1 to 2022. Then Hillary chooses positive integer b in response with b from 1 to 2022. where here also A from 1 to 2022, where B may equal A. Next, they consider the sequence with nth term given by an plus b for n 1, 2, 3, and so on if at least one term in the sequence is a multiple of 10, Freya wins the game, and if not, Hillary wins the game. Explain why, if Freya chooses A equal to 2017, Hillary cannot win the game. Okay, so let's go and support A first. Our sequence is what? It says an plus b. A is 2017. 2017, n plus b. Okay. It means Hillary cannot win the game. It means that at least one term in our sequence is multiple of 10. So let's see why. For any b, we should prove. So I want to see how can we say it is 0 mod 10. Look, 2017 n plus b. We want to find n in terms of b. Then we can say for all b's it work. 2017 mod 10 is 2. Sorry, 7. 7n plus b, or we can say 7n is congruent to negative b mod 10. Then I multiply both sides by 3. Why I multiply by 3? Because I want to reach a coefficient 1. Here we cannot divide, because maybe b is not multiple of 7. And also if you divide, it has some points that you should pay attention to. Divide 10 over GCD of 10 and 7, which is 1. So I multiply it by something to reach 1 more than 10 multiple of 10, or 1 less than multiple of 10. Why? I will show you. Here I write it times 3. Here why? Because 2017 is 7 mod 10. Here it's negative 3b, because we multiply both sides by 3. 21 is 1 mod 10. So n is congruent to what? Negative 3b. So 21 is 1 mod 10. I don't write mod 10, all of them are mod 10. Mod 10. So look, for any, maybe you say, okay, negative 3b is negative, but it has a remainder when divided by 10. Also, if it was 0, it is not important. You add 10. You add 10, 10, 10, negative 3b, 10, as much as you want. Okay? And if you add enough 10, it will be positive. Okay? And if when it was positive, you consider this one as, for example, k. Okay, mod 10. So if n equal to k, which k is positive, then it will be multiple of the term in our sequence will be multiple of 10, and Freya win the game. So we proved part A. Now, part B. It says if Freya chooses A equal to 2015, for how many values of B will Hillary win the games? Let's solve this part. Okay. A equals 2015, so it will be 2015 n plus b. I want to find a term that is multiple of, I want to see for which b I can find a term that is multiple of 10. Okay, so I want to find first for which cases Hillary win, if Freya wins, then for other cases Hillary win the game. Okay, so let's consider under what case. It says Freya win the game. So here, because it is multiple of 5, it is multiple of 5. So b should be multiple of 5. Okay. So one necessary condition is 5 divides b, and b is 5b prime. So I replace it with 25n plus 5b prime is congruent to 0 mod 10, mod 10. Then we divide both sides by 5. So it will be 403n plus b prime is 0 mod 10 over GCD of 10 and 5, which is 10 over 5, which is 2. Okay, it is a rule in when you divide in modular. If you don't know that, let me write it here. When, for example, ax is congruent, because we have a, let's write cx. It is a lemma, not related to only this problem. Mod m, then if you divide by c, it has a proof and it's not hard. X is y mod m over GCD of m and c. Okay, you should memorize. And because GCD of 5 and 10 is 5, so you divide it by 2. It is equivalent, these two things. And now you can say, okay, if you consider mod 2, it is n is congruent to negative b prime. Okay? For any b prime, it will be good. Because you can find a good n, you can add 2 as much as you can to reach a positive number. Okay? For that too, we have a good n. So for any b prime, it will be good. So multiples of 5 are bad. Are bad for Hillary. Are good for Freya. So b can be what from 1 to 2022? So the answer is 2022 minus multiples of 5 for Hillary. 2022 over 5. Floor of that. It will be 2022 minus 404. 12 minus 4 is 8. It's 1. 1 minus 0 is 1. 10 minus 4 is 6 and 1. Okay, so it will be 1618 for this problem. And part C, last part of the problem. It says for how many values of A is it guaranteed that Freya will win the game no matter Hillary's choice of B? You should make it clear which values of A are included in your count, why Freya always wins for those values of A, and how Hillary can win for all other values of A. It means that you should explain completely with proof. So let's see. This one, part C, I use again a small example. As you can see in all problems that we are solving, we should use the small examples. So suppose how many values of A, and also we can use previous parts. So for previous parts, look, A was 2017. It says for which values of A, it is guaranteed that Freya will win the game. If case 1, GCD of A and 10, like first case, for 2017, what we did, we found a good coefficient. First, we consider 7, then we multiply by 3, then we reached coefficient 1, and it was good. So if GCD of the coefficient and 10 is 1, then Freya can win, always. Otherwise, GCD of A and 10 is not 1. Means what? Case 2, 1. GCD of A and 10 equal to what or what? 2. Case 2, 2. GCD of A and 10 equal to 5. Case 2, 3. GCD of A and 10 equal to, let me tell you, to 510. Now, this case 2 is similar to case B. This case 1 is similar to case A. Okay, to part A. If GCD of A and 10 is 1, I want to say that always you can find a good n that it is multiple of 10. Why 0 mod? The reason is that you can find, for example, A1 such that, because when GCD, it is a theorem. There exists A1 that AA1 mod 10 is 1. Okay, and it has a proof. If you want to learn the proof, again, feel free to send message to my WhatsApp number in the description comment. So we multiply by A1. And because it is mod 10, we can only prove also for small values of 10. But in general, for any, instead of 10, if we had n or m, any value, we can find multiplicative inverse. We call it multiplicative inverse, for example, mod 10 or mod any number. Let me tell you how can we prove. For example, if A is 1, 1 times 1 is 1 mod 10. 2 GCD of 2 and 10 is not 1, 3. 3 times 7 is 1, so obviously 7 times 3 also is 1. 4, 5, 6, 7, 8, 9. 9 times 9 is also 1. Okay, for all of this, so we don't need to prove this theorem. But if you wanted to learn the proof of this theorem, because we should use an important one solution, we should use an important idea, and that is useful in many other problems. If you want to learn that technique in number theory, feel free to send message on my WhatsApp number in the description comments. Suppose AA1 is 1, so we multiply AA1AN plus A1B is 0 mod 10, because AA1 is 1, so N is congruent to A1B mod 10. And we can add as much as we want, 10 to reach a positive number, so N is that, mod 10. So we proved part 1. So for these values of A, it is guaranteed that Freya will win the game. And now we want to calculate the rest. Rest was this. Let me go to main problem. Okay. And it says what for how many values of A? Uh-huh. So for how many values of A, it is guaranteed that Freya will win the game. So here we prove this case. At the end, we will calculate them. Okay. Now we want to prove for cases 2, 1, 2, 2, 2, 3, Hillary can win the game. Okay. So can select a good. She can select a good B. For 2, 1, suppose GCD is for case 2. GCD of A and 10 is 2. So A is even. A is, for example, 2A1 or A, let's say, for example, 2T. So AN plus B is what? Is 2TN plus B. Can you say if Hillary selects which B, then it won't be multiple of 10? If B is 1, then it will be always odd. So an odd number cannot be multiple of 2, so it cannot be multiple of 10. Case 2, 2. GCD of A and 10 is 5. A is, for example, 5W. Okay, AN plus B will be 5WN plus B. Again, which B is good for Hillary? B1. Again, the remainder when divided by 5 will be 5. It is not multiple of 5, so it cannot be multiple of 10. If GCD of A and 10 similarly is 10, again similar. We say A equal to 10Z, AN plus B equal to 10ZN plus B. So if B is 1 again, the remainder when divided by 10 is 1, and it cannot be multiple of 10. Okay? Now we've proved in these cases Hillary win the game, and the problem says for how many values of A, it is guaranteed that Freya will win the game. So we should find GCD of A and 10 equal to 1. A is from 1 to 2022. So A is from 1 to 2022, and GCD of A and 10 is 1. So for this one, we should use pi, principle of inclusion and exclusion. Okay, so you say we have 2022 numbers, then what numbers are bad? The numbers that are multiple of 2 or multiple of 5. So, for example, it is A2, it is A5. A2 are multiple of 2. 2, 4, here 5, 6, 8, 10, 15, and so on. Okay? We want to calculate the numbers outside. For example, 1, 3, 6, 7, and so on. We want to calculate these numbers. Okay. So we say 2022 minus multiples of 2. So 2022 over 2 minus, it is integer, you can also write it floor. 2022 multiples of 5 minus 5. But we've subtracted multiples of 10 twice. So we should add them because we should subtract ones, bad numbers. So it will be this. Now let's calculate. It will be 2022 minus 1011 minus 404 plus 202. And if we add and subtract these numbers, it will be 1011. This number will be minus 202. Minus 202. 11 minus 2 is 9. And it will be 0. 0 minus 0 is 0. And 2 minus 10 is 8. So the answer is 809. Numbers are good. Okay, so we solved this problem, and also I've told you pi is what here. I release the solution of this. You can check my channel. This one you can do it as homework. Again, with a similar idea. With in some of my videos, I solved this for preparation for some exams. You can check them, or if you had question how we can easily solve it with a small example, feel free to send message to my WhatsApp number in the description and comments. Also, these problems of AMC 12A 2022, I released full solutions of this exam. You can use that. Also, this one, you can see how I've used a small example. This one casework. This problem is for Harvard MIT Math Tournament. We can do this one. Also, this problem, we can solve it with casework and some important ideas. Try to do them as homework. And again, as I said, like this one, I released full solutions of this exam, 2022 12A. Again, if you had question or wanted to learn more ideas, feel free to send message to my WhatsApp number in the description comments. Similar triangles, Pythagorean theorem, double Pythagorean theorem is what I call some problems because this idea is so much useful in AMC and AME. In many exams, I call this to remember what should we do and understand it is important. The name is not so much famous. Also, for example, we have ratio lemma. This is a bit more famous. And cosine law, sine law, some important 40, 50 important formulas in geometry. And if you want to learn them, feel free to send message to my WhatsApp number. And this problem, again, do this one as homework. It's easy, similar problem, easy problem for Stanford. This problem for 2022 AMC 12B. I released the solutions of this. This problem is a bit harder. The previous problems were so much easy. Try this one. Again, similar triangles, congruent triangles, all of them useful. Pythagorean theorem. You can use them to solve this. Okay. So if you had any question about the solutions of homeworks or wanted to learn more ideas or wanted to prepare for any exam, Mathematical Olympiad for girls, BMO1, BMO2, AMC, AME, USAMO, IMO, or for example, Senior Mathematical Challenge, SMC, IMC, JMC, and for any level of math exams, each exam has some important ideas that are repeated in all years. For example, I told you some ideas that are repeated in UKMT Mathematical Olympiad for Girls 2023, 2022, 2021, and so on. Okay, so as I said before, if you had any question or wanted to learn 40, 50 important ideas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message my WhatsApp number in the description and comments.